Hey guys, this video is to demonstrate the finite state machine two-piece counter. Look at this state diagram from 0, 0 to 0, 1 to 1, 0 to 1, 1 and repeat this pattern. We already talked about how to get this circuit step by step from this state diagram in that book, Understanding of Finite State Machine. We also demonstrate how to use simulation program, which is Quartus 2, to simulate the circuit in that book. Here we just build a real circuit in that breadboard to visualize the circuit working. This is a very simple circuit. We use one chip, 74, ACT 74, which is a dual D flip-flop. Another chip, 74, HTC 86, which is exclusive OR gate. For the D flip-flop, look at this 74 AS74. Look at this datasheet. There are two synchronous inputs. One is PR, which is preset. Another one is CLR, which is clear. Both of inputs are active low. You can see one bubble over there. Due to the circuit requires the D flip-flop work as a synchronous operation, we will disable those two inputs. So we can connect those two inputs to VCC, which is 5 volts. We also use 155 timer as clock input for the D flip-flop. Here is one formula to get the output frequency. In order to observe the state transition easily, we need to get a very low frequency. So we choose 1.2 kiloohms for R1, 18 kiloohms for R2, and 10 microfarad for C1, 0.015 microfarad for C2. For C2 is a decoupling capacitor that is optional. You may leave it open. Apply those value of components into that formula. We can get the frequency is 3.87 Hz. Also, we connect one red LED to the output of the 55 timer. So that's easy to observe the output frequency. The output of D flip-flop QA and QB connect to the input of exclusive OR gate. The output of exclusive OR gate is input for DA, and the QB NOT output is input for DB. Also, we set the output QA as most significant bit, QB as the least significant bit. In order to observe the state transition easily, we put one red LED for QA and one yellow LED for QB output. After circuit running, red LED suppose follow the pattern is 0, 0, 1, 1, and the yellow LED suppose follow the pattern 0, 1, 0, 1. Look at this state diagram again. This is a binary number, is 0, 0 to 0, 1 to 1, 0 to 1, 1. If we convert it to decimal number, it is suppose from 0 to 1 to 2 to 3 and repeat. If there is a decimal number display, that will be easier to observe. So based on that, we put one 74 LS47, which is BCD to 7 segment decoder, and one anode, common anode 7 display connect to this circuit. In 74 LS47, the unused pin 3, 4, and 5 can be left open. The pin 3 is lamp test. Pin 4 is blanking input, rumple blanking output. Pin 5 is rumple blanking input. All those pins are active low. If we use more 7 display, we will use pin 4 and pin 5 and connect randomly. Here we just use 1/7 display to show one single decimal number, so we can leave those 3 pins open. The pins, the 7, 1, 2, 6 are inputs. Also is A4 to 1, that's for that hex number input. So be careful, the pins 2 and 6 are supposed to be connected to the ground, because this is only 2-bit counter. If you leave and use the pins 2 and 6 open, you will reach wrong result. The pin 1 connect to QA output. Pin 7 connect to QB output. The outputs A, B, C, D, E, F, G are all the active low. Those pins connect to corresponding pins for common anode 7 display through resistors 120 ohms. The middle pins of the 7 display are connected to the VCC, which means 5 volts. For this circuit, for the power source, we use one power out pins from one microcontroller board. If you don't have those kind of power source, you might use one 9-volt battery connected to one regulator 7805 to get 5 volts output. See, look at this circuit working. This chip is a 5-5 timer. This LED indicates output frequency. This 2 LED, yellow LED is a QB, the red LED is a QA. The yellow LED follows pattern 010101. The red LED follow pattern is 0011. See, sometimes it's not easy to observe this pattern. That's why we use this 7447 decoder and the 7 display. You can see the decimal number in that 7 display from 0123, 0123, 0123, and repeat. This is a finite state machine 2-bit counter. Thank you for watching this video.